Assalamualaikum and good day to everyone. I am Dr. ROSMIZA from Faculty of Science, University Technology Malaysia. I would like to give a lecture on the introduction to material balance of bioreactor. Before we begin the class, I would like all the participants can join our WhatsApp group of Bioprocess Engineering 2022. So for today's lecture, I will cover 3 different subtopics which are thermodynamic preliminaries, law of conservation of mass, identification of material balance elements. So the course learning outcome from this topic is to demonstrate the material balance in bioreactor system. So as the introduction of material balance, so in material balance, we will consider the inlet materials to the bioreactor, which will be include the substrate, the microbe, oxygen, and so on. And we also will consider the outlet materials of the biomass, carbon dioxide, water, if the process is aerobic process. Alright. I also will introduce the type of process, which is batch, fed batch, and the continuous. And the system which we will cover in this topic is steady state, but I will give you a very general description of the system, either it is steady state or unsteady state. So as for the thermodynamic preliminaries, right? So we have a system, we have the process, and we also have the steady state and equilibrium. What do I mean with the system is it consists of method identified for investigations. And as for the process, it's a process causes the changes in the system or surroundings. And as the process either it's steady state or unsteady state, so steady state refers a state or condition which does not change with time. Alright, in thermodynamic system, we will have the system, the boundary, and the surrounding. So let's say we consider a cup of coffee here. We have a system which is a coffee itself, which was mixed with the sugar, and we get to stir so that the sugar will be dissolved in the coffee. And we also have a boundary, and this is the boundary is considered as a mark, and the surround here where the heat will be transferred from the system to the surrounding, and the mark will feel hot, right? So another example that you can see here is we have a 3 different system, which are open system, closed system, and isolated system. When we consider as open system, there is exchange of energy and matter, and if it is a closed system, also its only energy is exchanged from the system to the surrounding. And when it is isolated system, so there is no exchange of energy and matter between the system and the surrounding. So let us do on the activity number 1. Can you please give an example of process that involve a thermodynamic system? So you may write your answer. There are a few answers here, if you can see, and you might add on another examples by click here. Right. So the system, right, is divided by 2: open system and closed system. So open system is the example of open systems are semi-batch, the fed batch, and continuous process. All are either they are fed with the inlet materials, or as a continuous process they are inlet and outlet flow from the system. As the closed system, example here is a batch process where there is no inlet and outlet during the process. So this is the how we try to understand what is means by the closed system, where there is no inlet and outlet. and the volume of the system is constant, where at the biomass, the substrate, and the product varies with time. Okay. As for the fat batch or semi-batch process, so we have only our inlet, where the volume will not be constant, but there is variations of concentrations of biomass, substrate, and product. As for the continuous culture, we will have inlet and outlet flow from the system during the process. So where is the volume, the biomass, the substrate, and also the product will be constant throughout the process. Alright, this is the summarize of the fermentation process for batch and fat batch and continuous. So in general, normally in the lab scale, or if they are looking for the batch process, there is a low risk of contamination and stream mutation. As for fat batch, they are trying to prolong the log and stationary phase. As for continuous, so there is less of sterilization and re-inoculation, less maintaining costs, and faster substrate utilization rate. So as for the process, it was divided into two, which is steady state and unsteady state. So as for unsteady state, it is varies with time, and for steady state, it is not varies with time. Alright, as for the law of conservation of mass, we have three principles here. The first principle is mass is neither created nor destroyed during any chemical reactions. Principle number 2, no new atom is created or nor all atom destroyed during any chemical reactions. Principle number 3, the total number of any given elements on the reactant side has to match that on the product sides. So as for example here, the 100 gram of ice cube will change to 100 gram of liquid water. The mass still the same before and after, only there is a physical change between the solid to the liquid. As for the molecules, if we see here, when there is a reaction of methane with oxygen, so we will have the product of water and carbon dioxide. The number of carbon, hydrogen, and oxygen are similar from when we compare between the reactor side and the product side. Okay, let us do the activity number 2. You just click the Kahoot here and you can have a try. Alright, so what happens if there is a materials into the reactor and there is a materials out from the reactor, and they also have a reaction inside the reactor? So what will happen if the material, inlet material, is not similar to the outlet material? Okay, what happened to the system? Can you give your answer by click on this polev.com, and then you can share your opinion why the inlet material is not equal to outlet material. Alright, this is one example, the batch process of tempoyak, where it make it from durian after and fermentations for up to 7 days in anaerobic condition. Alright, if you look at here, we have a durian here, and then when it mixes with salts and it ferments at 4 to 7 days, and there is a few microbes involved inside the fermenter or the closed container, and the output will be the tempoyak. And this is one very simple example of the batch process. Alright, so the last activity, I hope you can click here, read and extract the main information of fermentation process from this article. Then let us try this activity number 4 by answering this live worksheet. So just click here put your name, what is the materials in, you have to extract the info of materials in, and what will be the condition of the system, and what will be the microorganism involved in this process. Alright, last but not least, I would like to have your feedback about my lecture. What need to be improved so that my lecture is much interesting after this. Alright, I think that's all. Thank you so much for listening. See you again, maybe in next lecture. Bye bye.